In the depths of the early universe, when space was just beginning to form the first stable structures, there was already something that disrupted the usual order of growth and time. An object that absorbed matter at such a speed as if the cosmos itself did not have time to cool around it. Its designation, SMBH J0313-1806, was a trace of the presence of a force that arose in an era when galaxies were still ignited by the first flashes of stars. In this region of space, light does not just move, it seems to lose its confidence, to slow down in the presence of colossal gravity, which distorts the very fabric of reality. Matter that is too close ceases to exist as an independent structure, disintegrating into a stream of energy that goes inside the invisible center. There is no surface, no boundary, only a continuous descent into the depths, where habitual laws cease to give the usual answers.
A young galaxy was forming near this object, which had not yet acquired its final form. Gas clouds stretched in long streams, collided, condensed, and ignited by the first generations of stars. But even in this chaos of growth, the influence of the center was felt, implicit but continuous. It directed the movement of matter, gathered it into dense regions, accelerated the evolution of structure, as if the early universe was forced to evolve faster than its own laws allowed. The accretion disk around SMBH J0313-1806 is a bubbling ring of energy where matter is heated to extreme temperatures. Before disappearing beyond the event horizon, it emits a colossal amount of light that travels billions of light years of space before reaching the observed epoch. This radiation carries information about the past, about the time when the cosmos was less orderly, denser, and younger.
There is no silence in this region in the usual sense. There is a constant interaction of forces. Gravity compresses, radiation tries to escape out, magnetic fields twist plasma into complex structures. Streams of matter are sometimes ejected outward in the form of narrow relativistic jets extending far beyond the galaxy. These jets pierce the surrounding space, heating the intergalactic medium and leaving traces of energetic impact visible on a huge scale. SMBH J0313-1806 existed in an era when the age of the universe was less than 1 billion years. This means that its mass has grown to billions of solar masses in an extremely short space span. Such rapid growth requires conditions in which the influx of matter was continuous and intense. Gas flows, devoid of heavy elements, fell freely into the gravitational funnel without encountering the resistance that would appear later in more mature galactic environments.
The galaxy surrounding this object itself is in a state of formation. Its structure has not yet been fixed into a stable spiral or elliptical shape. It is a dynamical system where dense regions are replaced by sparse ones, where stars are born and disappear in rapid cycles. At the center of this process is a massive object whose influence determines the trajectories of matter on scales comparable to entire star systems. The radiation coming from the vicinity of SMBH J0313-1806 is not always stable. It changes depending on the amount of falling matter, creating periods of strengthening and weakening. At moments of maximum activity, the center becomes one of the brightest sources of energy in the entire observable early universe. This glow pierces the cosmic darkness, allowing us to study an era that would otherwise remain hidden behind billions of years of space expansion.
Around this object, space is curved so much that the trajectories of light and matter deviate from the straight-line paths. Even distant regions of the galaxy are affected by this deformation. The orbits of young stars become elongated and unstable, and gas clouds form complex spiral streams directed inward. At the innermost boundaries of the accretion disk, matter reaches states in which atomic structures cease to remain stable. Electrons and nuclei no longer form familiar matter, but go into a plasma state where energy dominates form. This is the last stage before disappearing beyond the event horizon, the point of no return beyond which information ceases to return to the outer universe.
Despite its destructive nature, SMBH J0313-1806 plays a key role in the formation of its galaxy. Its gravity contributes to the concentration of matter, accelerates the processes of star formation in certain areas, creating conditions for the appearance of new generations of stars. In this interaction, destruction and creation are linked into a single system of cosmic evolution. Over time, the surrounding galaxy will change. Gas flows will be exhausted, star formation will slow down, and the structure will become more stable and orderly. But the central object will remain the dominant force, retaining its influence for billions of years. Its mass will increase, although the rate of this growth may vary depending on the substance available.
From the depths of the early universe, light from this object continues to travel through expanding space. It carries information about the time when the first large structures were just beginning to form, when the cosmos had not yet reached its current complexity. Each photon that has reached the observed epoch is evidence of processes that took place under conditions that no longer exist in the modern universe. And in this stream of ancient light, there is a trace of an object that became one of the earliest supermassive black holes known today. Its existence raises questions about the rate of formation of such structures, about the mechanisms of growth, and about what conditions could have allowed the emergence of such a massive center in such a short cosmic time.
But space itself continues to move. The expansion of space does not stop. Galaxies move away from each other, and ancient light sources gradually go beyond the observable horizon. And somewhere in the depths of this expanding space, SMBH J0313-1806 remains as one of the earliest and most powerful traces of an era when the universe was just beginning to take shape as it is known today. As this region of the early universe continues to evolve, the processes around SMBH J0313-1806 continue to intensify, forming a complex dynamic where matter no longer moves chaotically, but is subject to a powerful central influence. Gas streams that were once freely dispersed in space are now increasingly being captured by the gravitational field and directed inward. This creates a continuous cycle of inflow of matter, keeping the object active throughout long cosmic epochs.
The accretion disk is becoming increasingly heterogeneous. It forms dense clumps of plasma that move at tremendous speeds, collide, disintegrate, and reassemble into new structures. Each such process is accompanied by releases of energy that extend far beyond the galactic center. These emissions interact with the environment, changing its density, temperature, and distribution of matter. The inner regions of the disk are a zone where the boundaries of familiar physics are blurred. Here, the motion of matter approaches relativistic velocities, and time itself near the center begins to behave differently relative to the outer regions of the galaxy. The energy flows become so intense that they form bright regions of radiation visible at vast distances on a cosmic scale.
SMBH J0313-1806 continues to grow, absorbing the surrounding matter. Its mass does not increase evenly, but in leaps and bounds, depending on the availability of gas and dense clouds. In some periods, growth accelerates when large structures that can provide a powerful influx of matter fall into the area of attraction. At other times, the activity decreases, but does not stop completely, maintaining a constant energetic influence on the surrounding space. The galaxy in which this object is located gradually acquires a more pronounced structure. Dense areas begin to form the rudiments of spiral arms, although their shape is still unstable and subject to constant changes. Stars are born in giant molecular clouds, where the density of matter reaches values sufficient for the beginning of gravitational collapse. These processes occur faster than in later epochs of the universe, since the composition of matter is not yet enriched with heavy elements that affect the cooling and dynamics of the gas.
The influence of the central black hole extends far beyond the immediate accretion region. Gravitational perturbations propagate through the galaxy, changing the trajectories of stars and gas clouds. Some regions become denser, contributing to accelerated star formation, while others lose matter being pulled toward the center. Thus, the system is in a state of constant redistribution of mass and energy. Relativistic jets that arise near the poles of the accretion disk continue to play an important role in the evolution of the environment. These narrow streams of particles travel at almost the speed of light, permeating interstellar and intergalactic space. Their effects heat the gas over enormous distances and can suppress or conversely stimulate the formation of new stars depending on local conditions.
Over time, the structure of the galaxy becomes more stable. Regions of active star formation begin to concentrate in certain zones, forming large clusters of young stars. These clusters gradually merge into the overall dynamics of the galaxy, creating a complex system of rotation and interaction. The central object remains a key element of this system, determining its overall gravitational architecture. The light emanating from the accretion disk of SMBH J0313-1806 continues to propagate through the expanding space of the universe. It carries information about the state of matter at the moment when the cosmos was still extremely young. As it moves, this light stretches, loses energy, but retains a structure that allows us to study the early stages of galaxy and supermassive object formation.
In the outermost regions of the system, the influence of the black hole weakens, but does not disappear completely. The orbits of the stars remain slightly distorted, indicating the presence of a powerful central source of mass. Even at considerable distances, subtle gravitational interaction persists, determining the overall shape of the galactic structure. Over time, SMBH J0313-1806 could become even more massive if the environment continues to provide sufficient influx of matter. However, as the galaxy evolves, the amount of available gas will decrease and growth will slow down. This will lead to a gradual transition of the system to a more stable state, where the activity of the central object will decrease, but its influence will remain dominant.
And yet, on the scale of cosmic time, this object remains one of the key elements of the early universe, demonstrating how quickly supermassive structures could have formed in the first billions of years after the emergence of space. Its existence continues to influence our understanding of the processes that determined the architecture of modern galaxies and the distribution of matter in the observable universe. In the depths of the early universe, where time has not yet acquired the usual density of billions of years of evolution,
systems like SMBH J0313-1806 become key nodes in the formation of the structure of the cosmos.
Their presence doesn't just record the existence of supermassive objects.
It shows that the growth of matter could have occurred at an incredible rate, almost breaking the expected limits of formation.
Around such objects, the space ceases to be uniform. It becomes structured by gravity, which not only attracts matter, but redistributes it through a complex system of flows. Gas clouds stretch into long filaments to form a cosmic web, where dense nodes become future galaxies, and voids expand and deepen. SMBH J0313-1806 is located in the center of such a node. Its mass determines the direction of movement of matter at enormous distances. Gas flows moving along cosmic filaments gradually lose their chaotic nature and begin to follow gravitational gradients. This leads to the accelerated growth of the central object, which absorbs matter faster than the equilibrium structure around it has time to form.
Accretion under such conditions becomes almost continuous. Matter does not come in separate portions, but in a constant flow, forming a stable energy process. The inner regions of the disk heat up to extreme temperatures, creating powerful radiation that allows such objects to be detected at distances of billions of light years. At the same time, the galaxy itself has not yet completed its evolution. Its shape remains unstable. It can resemble a chaotic cluster of stellar and gas structures, gradually moving into more ordered forms. Within this process, the central object acts as a stabilizing and at the same time destructive factor, accelerating some processes and suppressing others.
Over time, such systems become the basis of future large galaxies. Matter not absorbed by the black hole is redistributed into orbital structures, forming stellar disks and halos. These structures gradually condense, and the galaxy takes on a more pronounced shape. But even in the more stable stages of evolution, traces of early activity remain noticeable. The mass of the central black hole, the distribution of stars, and the chemical composition of matter all retain the imprint of an era when SMBH J0313-1806 was just beginning its rapid growth. And the light that left this region in antiquity is still continuing its journey through expanding space, carrying information about a time when the universe was young, dense, and much more dynamic than it is now.
As this system progresses, the influence of SMBH J0313-1806 begins to manifest itself not only in the central regions, but also on the wider scale of the surrounding space. The gravitational potential becomes so significant that it begins to form a stable structure of material flows linking the intergalactic medium with the center of the system. These streams look like thin but powerful threads through which matter slowly but continuously moves inward. Within these filaments, the density of matter is inhomogeneous. Regions of condensation are formed, where the gas begins to collapse rapidly, creating new foci of star formation even before it reaches the central zone. Thus, around SMBH J0313-1806, a whole chain of starbirth processes arises, stretched over vast distances.
The accretion disk is becoming an increasingly complex system. Its outer regions are relatively colder, but it is there that matter is collected, which then gradually descends inside. As it moves towards the center, matter goes through several energy transitions, each of which is accompanied by radiation emissions. These emissions form a complex spectrum of light that allows us to study the physical conditions in different layers of the disk. Near the event horizon, matter reaches a state of maximum energy before disappearing from the observable region of space. Magnetic fields are amplified here, twisting the plasma into spiral structures that can exist only for moments on a cosmic scale. These structures are unstable, but they are the ones that create the brightest bursts of radiation.
The relativistic jets that arise in the polar regions are becoming more pronounced. They pierce the environment, maintaining a narrow shape over vast distances. Inside these jets, particles accelerate to almost extreme speeds, creating powerful flows of energy that affect the evolution of the entire galaxy and even beyond. The galaxy itself is gradually beginning to show signs of structuring. The chaotic distribution of matter gives way to a more ordered system, where stars and gas clouds form rotational motions around a central mass. However, this equilibrium remains fragile as the constant influence of SMBH J0313-1816 continues to redistribute matter.
Over time, some of the matter is completely removed from the central regions. This leads to the formation of more sparse zones, which gradually stabilize. In these regions, the stars continue to exist, but without the strong influence of the central object, following calmer orbits. However, the core of the system remains extremely active. Periods of increased accretion are replaced by relative calm, but even in calm phases, the flow of matter does not stop completely. This maintains a constant energy emission that makes SMBH J0313-1806 one of the most powerful sources in the early universe.
The light from this object continues to propagate through expanding space, gradually stretching due to cosmological expansion. It carries information about the structure of matter that existed in the epoch when the universe was still young and dense. And as this light reaches later epochs, it becomes evidence of the processes that determine the formation of the first large galactic systems, where supermassive black holes were not an exception, but a fundamental part of the cosmic architecture. Over time, the activity of SMBH J0313-1806 gradually moves into a new phase of cosmic existence. The streams of matter that once continuously fed its growth begin to thin. The intergalactic medium is expanding, the density of the gas is falling, and the available fuel for accretion is becoming increasingly limited.
The accretion disk loses its former brightness. The energy of radiation no longer reaches the extreme values that were characteristic of the era of rapid growth. The outer regions of the disk remain faintly luminous rings of matter, gradually turning into rarefied streams. The inner regions are still held together by gravity, but their activity becomes less intense, sparse, and uneven. The relativistic jets that once pierced space over vast distances are beginning to weaken. Their power decreases, the structure becomes less stable, and their length decreases. They no longer form such a strong impact on the environment, and the galactic ecosystem begins to slowly transition to a calmer state. The galaxy around SMBH J0313-1806 continues to exist, but its evolution is changing its character. Star formation slows down as cold gas reserves are depleted. Young stars are becoming rare, and the bulk of the older generations of stars, formed during the era of active growth, begin to make up the bulk. The central black hole remains the main gravitational core of the system. Even without a powerful influx of matter, its mass continues to determine the structure of the entire galaxy. The orbits of the stars retain a stable shape, but without the previous dynamic rearrangement. The system gradually comes to a state of long-term equilibrium, where changes occur extremely slowly.
In this state, SMBH J0313-1806 becomes a dark but still colossally massive center. Its presence is no longer manifested by bright flashes of energy, but the gravitational trail remains unchanged. The space around it continues to be curved, and the movement of matter continues to be subject to its influence.
The light that once left this region during the era of its maximum activity continues its journey through the expanding universe. It carries with it the image of ancient space, a time when galaxies were just forming, when supermassive black holes were growing at incredible speeds, and when the structure of the universe was still taking its first forms. And even when the system itself loses its former brightness and passes into the stage of cosmic silence, its trace remains part of the overall history of the universe. SMBH J0313-1806 becomes not an event, but part of a fundamental process, a reminder of how quickly and powerfully matter could have formed in the earliest epochs of space.
But even after the weakening of activity, the story of SMBH J0313-1806 does not end. Slow processes continue to take place inside the galaxy, stretching over billions of years. The stellar orbits gradually change under the influence of gravitational interactions. Individual clusters are getting closer, and the remnants of gas clouds are still moving through interstellar space, sometimes falling back under the influence of the central object. Sometimes new flows of matter penetrate into the core of the system. This can happen during the approach to other young galaxies or when dense clouds pass through the central regions. SMBH J0313-1806 then begins to increase its activity again. The accretion disk is partially restored, the temperature rises, and the ancient center again emits powerful radiation. Such periods can last millions of years. For space, these are only brief flashes against the background of a huge time stream. But they are the ones that change the structure of the surrounding galaxy. The energetic emissions heat up the interstellar medium again, and the relativistic jets awaken and begin to cut through space. Over time, the galaxy around SMBH J0313-1806 may collide with another massive system. Then a gigantic gravitational interaction will begin. Star streams will intertwine, gas clouds will lose stability, and the central regions of both galaxies will gradually converge. Within this process, two supermassive black holes can begin to move around a common center of mass. Their orbits will slowly shrink due to the loss of energy due to gravitational waves, oscillations in the very fabric of space-time. These waves will propagate through the universe, carrying away information about a colossal event. When the distance between objects becomes critically small, a merge will occur. Huge masses will unite into a single supermassive object, even more powerful and heavy. The space around it will shudder from the release of energy, and the new black hole will receive an additional impetus of movement within the renewed galaxy. After that, the system will begin a long path of evolution again. The new galaxy will become larger, more massive, and more stable. At its center will remain a giant black hole, the heir of the ancient SMBH J0313-1806, which has retained the mass accumulated in the era of the young universe. Billions of years pass. The universe is getting colder and darker.
galaxies are moving farther apart, and the gas needed to give birth to new stars is gradually drying up. The luminous regions are becoming smaller. Outer space is slowly turning into an era of fading activity. But supermassive black holes continue to exist. They experience stellar generations, changes in galaxies, and even the gradual cooling of space. Their gravity remains unchanged, and the mass holds a history of countless epochs of accretion and mergers. And somewhere in the depths of the future, among sparse stellar remnants and near empty space, the descendant of SMBH J0313-1806 will still be at the center of an ancient galaxy, almost invisible, surrounded by darkness and cold. It will retain a trace of one of the earliest eras of the universe, a time when the cosmos was just beginning to build its first gigantic structures. Over time, even the most stable structures in the universe begin to undergo slow but inevitable changes. The galaxy, with SMBH J0313-1806 once shining at its center, is gradually losing the remnants of its former activity. Stars born during the epoch of rapid formation continue their movement in stable orbits, but new generations appear less and less until the process of star formation is almost completely extinguished. The gas that once filled the space between stars was either absorbed or dissipated in the intergalactic medium. The remaining clouds become too sparse to trigger new cycles of star birth. The galaxy enters a phase of long decay, dominated by cold stability and slow motion of matter. The central black hole remains the only truly active element of the system, although its activity is no longer comparable to that of ancient eras. Sometimes, after billions of years, it can receive an influx of matter again. Single stars lost in the gravitational field, or residual gas flows. These rare events cause brief flashes of radiation reminiscent of past greatness. But mostly, SMBH J0313-1806 and its successors exist in a state of near total silence. Their presence is determined not by light, but by gravity, an invisible but dominant force that keeps rare stars in orbit and retains the shape of the galaxy even in the face of cosmic aging. On the enormous scale of time, a new stage begins, the epoch of the disintegration of galactic structures. Gravitational interactions between stars lead to a gradual redistribution of orbits. Some stars leave the system for intergalactic space, while others slowly approach the center, where they can be swallowed up by a black hole. But even this process is extremely slow. Time becomes the main factor in evolution. Everything that happens is stretched out so much that it is difficult to distinguish change from immobility. And yet, despite the fading, the trace of SMBH J0313-1806 does not disappear. It remains embedded in the very structure of the space around it, like an ancient knot of mass formed in an era when the universe was just beginning to create its first large systems. And as long as the cosmos exists, this trace continues to exist with it.